Graphene is the thinnest material known to mankind. It is 1 atom thick and weighs less than 0.77 milligrams per meter squared. Graphene is composed of carbon atoms linked in hexagonal shapes in single 2D sheets. Now, this type of linkage is not to be confused with fullerenes, wrapped graphene, nanotubes, rolled graphene, or graphite. Although they all share the hexagonal shape, it is only graphene that is two-dimensional. It is an sp2 bonded molecule with a molecular length of 0.142 nanometers. The history of graphene goes further back than most people think. Technically, it was discovered in the 1800s through finding the atomic weight of graphite. In 1947, the official work on graphene was written by P.R. Wallace. Then, in 1948, a single layer of graphite was isolated by Ruiz and Voigt. The next advancement in graphene history was in the 1970s when scientists found a way to deposit graphene monolayers onto other materials. However, the efforts to isolate graphene itself were initialized in 1990. The first patent for graphene was filed in 2002, and in 2004, Geim and Novoselov successfully pulled graphene from a block of graphite using the Scotch tape technique. However, all this history would be useless if graphene didn't have a function. This substance is highly versatile given its physical and chemical properties and can be used as anything from a conductor to an energy store. Some of its applications include batteries, supercapacitors, paint, flexible displays, solar panels, bomb detection sensors, and more. Along with such a versatile molecule comes a variety of hazards and benefits to the substance. Benefits are that graphene is relatively cheap, it is helpful in water desalination, and is an environmentally friendly fuel cell and/or solar panel. This molecule is far from perfect, but it does have very few hazards, those being its incredible mobility in water and toxic effects on the human respiratory system. Now, this substance is so useful that we would like to think that there are no problems with it and we can use graphene however we want. But there is the aspect of the environment to think about, and even though there are negatives, the positives outweigh them. As previously stated, graphene is very mobile in water, and this can cause different issues in different types of water. In groundwater, graphene tended to become less stable and slowly worked its way out of the water. In surface water, the graphene remains stable, but it travels further than the subsurface layers did before working itself out. As for positives, it can be used to desalinate water and as a method of water filtration because of its hydrophobia. Well, that's everything you ever wanted to know about graphene. Thanks for watching.